7 Quality Control Tools. 7 Quality Control Tools. 1. Cause and Effect Diagrams. 2. Flowcharts. 3. Check Sheets. 4. Histograms. 5. Pareto Charts. 6. Control Charts. 7. Scatter Diagrams. Rules. Diverse group. Go around room and get input from all, 1 idea per turn. Continue until ideas are exhausted. No criticism. Group ideas that go together. Look for answers. 1. Cause and Effect Diagrams. Fishbone Diagram. Purpose: graphical representation of the trail leading to the root cause of a problem. How is it done? Decide which quality characteristic, outcome or effect you want to examine. May use Pareto chart. Backbone: draw straight line. Ribs: categories. Medium size bones: secondary causes. Small bones: root causes. Benefits: breaks problems down into bite-sized pieces to find root cause. Fosters teamwork. Common understanding of factors causing the problem. Roadmap to verify picture of the process. Follows brainstorming relationship. Please look at the sample fishbone diagram for better understanding. 2. Flowcharts. Purpose of flowcharts: visual illustration of the sequence of operations required to complete a task. Schematic drawing of the process to measure or improve. Starting point for process improvement. Potential weakness in the process are made visual. Picture of process as it should be. Benefits: identify process improvements. Understand the process. Shows duplicated effort and other non-value-added steps. Clarify working relationships between people and organizations. Target specific steps in the process for improvement. Benefits: simplest of all flowcharts. Used for planning new processes or examining existing one. Keep people focused on the whole process. How is it done? List major steps. Write them across top of the chart. List sub-steps under each in order they occur. Benefits of flowcharts: linear. Show what actually happens at each step in the process. Show what happens when non-standard events occur. Graphically display processes to identify redundancies and other wasted effort. How is it done? Write the process step inside each symbol. Connect the symbols with arrows showing the direction of flow. Please look at the sample linear flow for better understanding. 3. Check sheets. Purpose of check sheets: tool for collecting and organizing measured or counted data. Data collected can be used as input data for other quality tools. Benefits of check sheets: collect data in a systematic and organized manner. To determine source of problem. To facilitate classification of data, stratification. 4. Histograms. Purpose of histograms: to determine the spread or variation of a set of data points in a graphical form. How is it done? Collect data, 50 to 100 data point. Determine the range of the data. Calculate the size of the class interval. Divide data points into classes. Determine the class boundary count. Benefits of histograms: allows you to understand at a glance the variation that exists in a process. The shape of the histogram will show process behavior. Often, it will tell you to dig deeper for otherwise unseen causes of variation. The shape and size of the dispersion will help identify otherwise hidden sources of variation. Used to determine the capability of a process. Starting point for the improvement process. 5. Pareto Charts. Purpose of Pareto Charts: prioritize problems. How is it done? Create a preliminary list of problem classifications. Tally the occurrences in each problem classification. Arrange each classification in order from highest to lowest. Construct the bar chart. Benefits of Pareto Charts: Pareto analysis helps graphically display results so the significant few problems emerge from the general background. It tells you what to work on first. 6. Control charts. Purpose of control charts: the primary purpose of a control chart is to predict expected product outcome. Benefits of control charts: predict process out of control and out of specification limits. Distinguish between specific, identifiable causes of variation. Can be used for statistical process control. Strategy for eliminating assignable cause variation: Get timely data so that you see the effect of the assignable cause soon after it occurs. As soon as you see something that indicates that an assignable cause of variation has happened, search for the cause. Change tools to compensate for the assignable cause. Strategy for reducing common cause variation: do not attempt to explain the difference between any of the values or data points produced by a stable system in control. Reducing common cause variation usually requires making fundamental changes in your process. Control chart decision tree. Determine sample size, n, variable or attribute data. Variable is measured on a continuous scale. Attribute is occurrences in n observations. Determine if sample size is constant or changing. Please look at control chart decision tree for better understanding. What does it look like? Adding the element of time will help clarify your understanding of the causes of variation in the processes. A run chart is a line graph of data points organized in time sequence and centered on the median data value. How is it done? The data must have a normal distribution, bell curve. Have 20 or more data points. 15 is the absolute minimum. List the data points in time order. Determine the range between each of the consecutive data points. Find the mean or average of the data point values. Calculate the control limits, 3 standard deviations. Set up the scales for your control chart. Draw a solid line representing the data mean. Draw the upper and lower control limits. Plot the data points in time sequence. Next, look at the upper and lower control limits. If your process is in control, 99.73% of all the data points will be inside those lines. The upper and lower control limits represent 3 standard deviations on either side of the mean. Divide the distance between the center line and the upper control limit into 3 equal zones representing 3 standard deviations. Search for trends. 2 out of 3 consecutive points are in zone C. 4 out of 5 consecutive points on the same side of the center line are on zone B or C. Only 1 of 10 consecutive points is in zone A. Basic control charts interpretation rules. Specials are any points above the UCL or below the LCL. A run violation is 7 or more consecutive points above or below the center, 20 to 25 plot points. A trend violation is any upward or downward movement of 5 or more consecutive points or drifts of 7 or more points, 10 to 20 plot points. A 1 in 20 violation is more than 1 point in 20 consecutive points close to the center line. 7. Scatter diagrams. Purpose of scatter diagrams: to identify the correlations that might exist between a quality characteristic and a factor that might be driving it. A scatter diagram shows the correlation between 2 variables in a process. These variables could be a critical to quality (CTQ) characteristic and a factor affecting it. 2 factors affecting a CTQ or 2 related quality characteristics. Dots representing data points are scattered on the diagram. The extent to which the dots cluster together in a line across the diagram shows the strength with which the 2 factors are related. How is it done? Decide which paired factors you want to examine. Both factors must be measurable on some incremental linear scale. Collect 30 to 100 paired data points. Find the highest and lowest value for both variables. Draw the vertical, y, and horizontal, x, axes of a graph. Plot the data. Title the diagram. The shape that the cluster of dots takes will tell you something about the relationship between the 2 variables that you tested. If the variables are correlated, when one changes the other probably also changes. Dots that look like they are trying to form a line are strongly correlated. Sometimes the scatter plot may show little correlation when all the data are considered at once. Stratifying the data, that is, breaking it into 2 or more groups based on some difference such as the equipment used, the time of day, some variation in materials or differences in the people involved, may show surprising results. You may occasionally get scatter diagrams that look boomerang or banana-shaped. To analyze the strength of the correlation, divide the scatter plot into 2 sections. Treat each half separately in your analysis. Benefits: helps identify and test probable causes. By knowing which elements of your process are related and how they are related, you will know what to control or what to vary to affect a quality characteristic.